So I'm going to do 3 examples of solving equations of quadratic form, and then there's a final video in this chapter where we talk about solving equations with rational expressions, which we did before in chapter 5. That's what gave a lot of students a lot of trouble. But they're making them slightly more complicated. So you want to go back and review chapter 5. And if your problem is with factoring, you have to review chapter 4. It's always good to review anyway. Think of it as studying for the final as well as getting ready to do this stuff at the end of this chapter. But for now, we're just doing some examples of things in quadratic form, solving polynomial equations of quadratic form. So this one here is the common example, right? 2x to the fourth minus 5x squared plus 3 equals 0. Your u is x squared. Now, if you can just do this problem without writing out the u, that's fine. But maybe starting out, you should write out u equals x squared. Like that. And then just rewrite it with the u. So now it's a quadratic, and I can solve for u. And you can do this. We have 4 methods, of which I would suggest using one of 3. Factoring, if it factors with integers, that's always the easiest way, if it factors with integers. You can't use the square rule here directly without completing the square first, and I don't recommend completing the square on these. So unless you're told to, which you won't be in this section. So we can use the quadratic formula. Let me see. Product of those is... Well, we can use the AC method to see if it factors. 2 times 3 is 6. And then we need... So that's positive. So we need 2 factors of 6 that add up to 5. That ain't going to happen. Well, yeah, it is. 2 and 3. Yeah, so that actually factors. Factors that way. Wait, yeah. You have to go through the process if you don't see how it factors. But we did the factoring before, so I don't really feel I have to go through the whole thing. I could see that it factored by thinking of the beginning of the AC process, and then I would just write out the whole, just go through the whole thing and figure out where the 2 and the 3 go. Okay, remember that involves, AC method involves factoring by grouping. Right? You have 4 terms, then you factor by grouping. Anyway, so we get this, and then we could solve for the u's, and then substitute the x back in, and then we'll actually use the square rule to figure out what the value of x is. Or we could put in the x here. Depends on what you want to do. I decided this time, I guess, I wrote them that way. So I just set each factor equal to 0. And remember, each of these now is actually a quadratic, each of these 2 equations, in x. So I decided I'm just going to solve for u on both of them. So I did that. That's pretty easy. Now, the thing is, you have to remember, see, the original equation doesn't have a u in it. It's 2x to the fourth minus 5x squared plus 3 equals 0. So you have to be careful with these that you put the x back in. So u is x squared, so you need to substitute the x squared in at this point. So I get these 2 different solutions. Well, 2 different equations. These are both quadratics, and there's only one term with an x in it. It's the x squared term. So you can use the square rule. Right? So you just get x equals plus or minus square root of 1, which is just plus or minus 1. Right? And you get x is plus or minus square root of 3/2, which I would just leave that way. You don't have to rationalize denominators unless you're told to. So I'm going to check them. Notice I'm checking them both at the same time. Why? If you look at the original equation, the lowest power of x is a square, and the other one is a 4th power. So if x is negative, you get the same thing as if x is positive. Right? So this x squared, negative 1 squared is 1, and 1 squared is 1, and negative 1 to the 4th power is 1, and 1 to the 4th power is 1. So basically, this one's pretty easy to check. You could probably just look at it and see. You get 2 plus 3 minus 5. 5 minus 5, 0. I like to do the positive ones together and then the negative ones together and then subtract. It's just easier. Now this one's a little bit more, but I can still do the positive and the negative because I'm still doing even powers of it when I plug it in. A square and a 4th power. And that's not going to be that hard because the square root goes away right away. Right? You do the 4th power, you do the square. Remember, the 4th power is squaring it twice. So you square the square root and you get rid of that, and then you square the 3/2 and you get 9/4. Right here, right, going from here to here. Now here, you're just squaring the square root, so you just get 3/2, and the minus would cancel because of the square, and so you can ignore the plus and minus. And then you have to see if this gives you 0 or not. So I reduce that. 2 over 4 reduces, and that makes it easy to combine these, right? Because it's 9/2 minus 15/2 plus 3. 9/2 minus 15/2 is 6/2. So it's minus 3 plus 3, or negative 3 plus 3. So that checked. The check actually took me longer than figuring out the solutions. Actually, it's about the same amount of writing. It's just the squares and 4th powers make the right side look larger. Okay, next example. I have 2 examples on the next video.